Hi, welcome back to our lecture. The first topic that I want to cover is service discovery. So, what is service discovery? Well, you can think of it as a process by which one service determines the location of another service. So, it's a process which allows one service to find another service. And this can be a really important challenge to solve because, imagine you have a cluster environment and you're deploying services into it. Well, those services may move around a little bit, especially if different server nodes within the cluster fail or availability zones fail. And so these services need to be able to sort of constantly monitor one another and be able to adjust to topology changes within the service architecture. And a simple example of service discovery is imagine you were deploying a web server. Maybe it's a WordPress web server, and that web server needs to be able to communicate with a database server, something like a Maria database or MySQL database. Well, how does the web server or web application running on that web server, how does it know where the database service is located? Well, up until this point in the course, we've basically been hard coding the value of that database server in the application server configuration. We've been hard coding that database service endpoint. But what if that database server, what if it changes? What if it moves around? We deploy it in a container in a cluster. It has an IP address. What happens if that changes? How does the web application know where the database server is located if it moves around? Well, it needs to use some sort of service discovery mechanism, and any sort of platform that leverages a multitude of services, like especially a microservices based architecture, will need to implement some sort of service discovery mechanism because these applications, these platforms may need to track potentially hundreds of different services. You might need to be able to support the versioning of services. How does an application know where version 1 of the service is versus version 2? And the application needs to be designed in a sort of resilient architecture so that if the topology of the underlying infrastructure were to change, if something were to fail, then application services could route around that failure, and they could use service discovery to do that. Well, so how do you actually implement service discovery? Well, there are two basic patterns that you'll find for service discovery. The first pattern is implementing some sort of server-side service discovery. And with server-side service discovery, the application connections are going to be proxied, and the discovery is going to be abstracted away. So applications don't know where these services are located because they communicate to a service via some sort of proxy. For example, you could envision something like a load balancer that is configured between a WordPress web server and a MySQL database server. The WordPress web server doesn't actually know where the database server is located. All it needs to know is where the load balancer is located. So it will communicate with the load balancer. The load balancer will proxy that request and send it on to the MySQL server. And it could have, it could be communicating with multiple MySQL servers, maybe even some read replicas. And if one of those replicas were to fail, then the load balancer recognizes the failure and is able to route requests to an instance which is healthy. So With the server-side pattern, you've got some sort of proxy that sits between the two services and abstracts away the actual service location. The other pattern that you'll find is what we call the client-side service discovery pattern. And in this pattern, you have application services which are communicating directly to other services. And they communicate via some sort of service registry. So the idea is that when a service is launched, it will register itself with the service registry, and then any service which wants to talk to that service would look for the location of that service in the service registry. And all of the load balancing is occurring client side. So if you have a client service that wants to communicate potentially with multiple services in a load balanced sort of fashion, then that load balancing would be handled by the client. There's no actual load balancer service that is proxying requests between the client and the services that it is communicating with. Well, so those are the two general patterns for service discovery. How do you actually implement service discovery in your platform? Well, traditionally, for decades, we would hard code our service locations into our infrastructure and our applications. And that was just simply because our infrastructure didn't change very often. If you can imagine like a traditional data center where you might have a web server, and that web server has a dedicated IP address, and then you'd have a physical database server, and that would have a hard-coded IP address. Those two servers, they weren't changing very often unless they were being replaced or updated or they're going under maintenance or something. But otherwise, we would maintain those servers, and if they became unhealthy, then it was a priority for us to fix the servers. The key is that those servers were sort of fixed in a location; they weren't changing very often. And so one of the mechanisms that we might use if instead of hard coding like IP addresses into our applications, we might leverage domain name services or DNS. And DNS, if you recall, is a mechanism by which we can map domain names, sort of real world names, to IP addresses. And that was a convenient service discovery mechanism for us, because we could give, instead of hard coding the IP address of the DNS server, we could give of the database server, we could give the database server a DNS name. We could call it database1.domainname.com, and we could plug that into our application configuration. And even if we change the IP address of the database server, as long as we updated that IP address in our DNS host file, then other services would be able to continue to find that database server, even though its IP address or even its location had changed. One of the problems, though, with DNS is that, if we fast forward to modern cloud applications where our infrastructure is more ephemeral and it is changing much more rapidly, well, our DNS was never really designed for this sort of dynamic infrastructure changes. Yes, we can use it and we can update DNS fairly rapidly, but there can be problems associated with clients caching DNS information. Another service discovery mechanism that we use, and we've used several times in this course, is leveraging an application load balancer for service discovery. And again, this addresses that server side service discovery pattern where we're abstracting away the location of the services that we're trying to communicate with. All we need to do is communicate with the load balancer endpoint, and the load balancer knows where the web servers are or the database servers are, and it's able to monitor the health of those servers and distribute requests to the healthy services. Well, what's the problem with this service discovery method? Well, the problem is that we still have essentially a service discovery problem. I mean, imagine you launch your service and it needs to communicate with a set of microservices, and it's going to do so through an application load balancer. Your client service needs to find out what the endpoint address is for the application load balancer. So how does it discover the application load balancer location? You still have a service discovery problem that you need to solve there. You have abstracted away the service location of those microservices that you want to communicate with, but you still need to figure out where the load balancer is located. Another method that you could implement is storing service information in some sort of distributed file system or a database. And you can envision a scenario where you have a microservice and it launches and it updates a table in an Amazon DB table. It updates an item in an Amazon DB table. And then that updated table will stream the data to Kinesis and then potentially update the configuration of consuming microservices. So that's potentially a solution where you're sort of pushing out configuration to services in that way. If you're using some sort of database to store service discovery information, then your biggest challenge is a sort of traditional distributed database challenge where you need some sort of lock mechanism or RAF logs or something in order to ensure the consistency of that data in that service discovery database. We could use, as another method, the outputs from our infrastructure definition tools like CloudFormation and use that as a service discovery mechanism. You can imagine where, like, let's say you had an application platform and you partitioned it into multiple stacks, multiple infrastructure stacks, each stack representing a different service in your platform. Each service which is launched by a stack would then output some information, some service discovery information describing the location of the infrastructure resources created by that stack. So you could have a stack that creates a database and it outputs the database endpoint address or the IP address for that database service. So you could sort of stitch together these outputs and use them as inputs into other stacks, and use those inputs use these outputs as a service discovery mechanism. Well, the problem with this sort of method is that you can't dynamically update the service discovery information when infrastructure fails. So the location of the database server is going to be correct at the time that the stack was launched, at the time the CloudFormation stack was launched. But if the database, if the availability zone that the database server is running in, if that fails at some point, then the location of the database server may change, and the consuming services, they wouldn't be able to look to CloudFormation for that new service location, because the outputs in the CloudFormation templates are fixed, and they're fixed at the time of the stack deployment. Probably one of the most common service discovery methods that you'll find today is leveraging some sort of dynamic service discovery platform. And the idea here is that you have a centralized service discovery service, essentially, that is persisting data and information about the location of services running within the platform. And each time you launch a service in the platform, maybe you're launching a catalog service or orders or UI, each one of these services would register itself with the centralized service discovery mechanism. So it would tell the service discovery mechanism where it is currently located, and then other services in the platform could query the service discovery service to find the location of other services that it wants to communicate with.